Hi, I'm Pushkar, Master Teacher in Chemistry at Vedantu, and I'm discussing KVPY 2019 SX Chemistry Paper Part 1. Here is a question from Chemical Kinetics. For a first order chemical reaction, the product formation rate is independent of reactant's concentration. Let's see that what kind of statement is this. The product formation rate is independent of reactant concentration. So suppose the reaction is A changing into B. So for this reaction, dB by dt must be equals to minus d by dt, and that must be equals to k times of A. So obviously the product formation rate is directly proportional to the concentration of A. So it could not be true. So the first statement is, of course, wrong statement. Second statement is the time taken for the completion of half of the reaction, T half, is 69.3% of the rate constant K. That's also seems to be wrong because the unit of K will be here time inverse, and the unit of this T half will be obviously T. So how you can compare T half with K? You could not. So obviously they are not dimensionally same, so there is no need of comparing this term. So B is also a wrong option. Third option is the dimensions of Arrhenius pre-exponential factor is reciprocal of time. This is the correct option because we know that k is equals to a to the power minus a by rt, and this e raised to the power minus a by rt is a dimensionless number because ea has a unit of energy, rt has a unit of energy. So of course e raised to the power minus a by rt is a dimensionless number. Okay, so we are left with only a. So whatever is the dimension of k will be dimension of a, and k here is in the dimension of k is time inverse. So the dimension of a should also be what? Time inverse. As simple as that. So option 3 is the correct option. And of course, the fourth option is that the concentration versus time plot for the reactant should be linear with negative slope. That is obviously wrong because concentration by T graph is exponentially decreasing. It is not linear. It is not linear. And how you can judge it? Because we know this expression, integrated expression for first order, which is a is equals to a naught e to the power minus kt. From where this exponential graph you're getting from the very famous integrated rate law. K is equals to 1 upon t ln of a naught by at. If you have any doubts, so just recall, you can write it like this, and which means that kt is equals to ln of a naught upon at, where a naught is the initial concentration, at is the concentration at time t, and by rearranging this e to the power kt, you can write it is equals to what? A naught upon at, and so you can easily get this expression that at, concentration at time t, is equals to a naught e to the power minus kt. So that is the integrated expression, which clearly gives us the idea that how the concentration is going to change with time. If you plot A versus T graph, that's going to be exponentially decreasing. And if you plot ln of A versus T graph, that is of course linear. So this particular graph is used for predicting whether it is a first order reaction or not. So very common question from the first order, very common question. This is the solution. Thanks for watching and stay tuned for other questions.